13 weeks. Okay, so chapter 2 deals with limits. The entire course deals with limits, and the next one, and the next one. So you will never get away from this, from limits in math. I'd like to start with 2 topics before we even talk about anything. The first topic is graphing a piecewise defined function. And you may say, why are they so important? So let me give you a couple of examples. And one that is coming up in April, on April 15th. So April 15th is the tax day. So why is the tax code a piecewise defined function? It's because I'm making up numbers. I really don't know. For this income, people pay 10%. For this income, people pay 15%. For this income, different income, of course, they pay 25%. For this, they pay 30%. So that's a piecewise defined function. It's defined in pieces for different values of x. Okay, so I'm going to choose a simple piecewise. No, I didn't mean that. I only meant to change this. So I'm going to choose a piecewise defined function, and there are many others. So I'm going to choose a piecewise defined function. If you want to help, help. So I'm going to use just 2 pieces for now. Simple, let's say x squared minus 4 for x less than or equal to 0. And a linear function like negative 2x for x greater than 0. I couldn't come up with a simpler piecewise defined function. So I want to say from the very beginning that if somebody graphs a function like this, a piecewise defined function like this, so one graph, let's say, on top of another graph, then you understand that this is not a function, right? By the vertical line test, this is not a function. So I'm going to say that from the beginning because I always see it, always. So every time we're asked to graph a function, we have to go through the following steps. Number 1 has to be domain. Number 2 has to be a table of values, or ordered pairs better. Table of ordered pairs. Number 3 has to be the graph. And number 4, the range. So please keep this in mind every time. Now, if the graph is quadratic, we may have to find the vertex, the axis of symmetry, yada, yada, yada. But in general, domain has to be the starting point, a table of ordered pairs in which we show if it's a simple situation, we want to use transformations, then we don't need to do this. Okay? But in general, domain, table of ordered pairs, the graph, and after we graph, we have to establish or state the range. I always say this to my students. I don't want you to change your method. Meaning, if you learned a particular method and you are comfortable with it, I'm fine with it. Any method. Sometimes I would say, try to understand this method because we're going to use it over and over. And I'm going to say this for this particular situation. Try to understand this method that I'm using because it will save you a lot of time when it comes to limits. It will save you a lot of time when it comes to graphing. So it will be rare when I say, just please. Also, in general, compare my method to your method. If it's better, use it. If it's not better, don't use it. Stick with your own, okay? That's fine. But this time I'm going to say, please try at least to understand the method. Okay, so I'm going to go back. Now here, when I look at this interval, I realize that in interval notation, this inequality in interval notation is nothing else but negative infinity 0 with a bracket. This is very clearly the 0 to infinity. And this really tells me that the domain of this function is what?
Negative infinity to infinity.
Perfect. So I established the first step is finished. So here's my table of ordered pairs. Here's function f of x. Here's negative infinity to infinity. And in the table, I have to have 0. 0 is a key x value. Why? Because as you see, this function has two pieces, and this changes into this if you want at 0, or vice versa if you want. This changes into this and there at 0. So I will put 0 in the table right in the middle, and under 0 I will have these two symbols, and they are touching. Okay, exactly under 0. So 0 and exactly underneath 0. I see it in my students' notes something like this. No. It's exactly under 0. So bracket to the left, because that's what it says, and parenthesis touching to the right. Now, if the function is not defined at 0, the parentheses will not touch, or if it has a different number. Okay? So parentheses cannot touch. The bracket and the parenthesis will, because 0 will be included here and 0 will not be included here. If it's in one or the other, they will be touching as symbols. If the function is not defined at 0, then I will be using this. Or if it's defined at a different number and I'm given 5, then I will write this. So parentheses will not touch, but the bracket and parenthesis will. My next step is I identify that between negative infinity and 0, I have to use this, which is x squared minus 4, which is quadratic. Obviously, between 0 and infinity, I have to use negative 2x. You can say, but I don't need to put those here. I already see them there. Yes, but sometimes I don't really do that to my students, but sometimes authors present them in the inverse order. So it's safer to write them on top of their own piece. Okay? So x squared minus 4 is for less than 0. And negative 2x is for greater than 0. Okay. At this point, I will choose, because I know how this function looks like, right? We all know how full x squared minus 4 looks like, right? We know that x squared is this, and that x squared minus 4 is this. So this is x squared, and this is x squared minus 4, and we know that it crosses at negative 2 and 2. But this is not what we're interested in, right? This is not what we are graphing. But what I'm meant to say is that I know that if I plug in negative 2, I get a 0. When I plug in 0, obviously I get negative 4. Notice that I wrote it right inside of the bracket. Not next to the bracket, but right inside the bracket. And then I want to plug in 0 here, and you will say no. And rightfully so. You will say, you don't have 0 here. It will not be a function. If 0 is here, it cannot be here. So how come that you plug in 0? Bear with me and you'll see what happens. So I plug in 0, I get 0, and I write it right inside the parenthesis. Of course, I need one more value because it's a line. So I get negative 2. Make sure that all these numbers are between negative infinity and 0, and these numbers here are 0 to infinity, because I saw a negative 2 here sometime. Okay, so now I'm ready to graph. So okay, so here it is. At negative 2, 0, as we knew. 0, negative 4 must be a full point. Why? because of the bracket. So this is full. And this is open. So I know the graph, it's quadratic. Done. Notice that I use the color for the left branch of this function, and I'm going to use a different one for the right branch in the hope, so it starts at the open point 0, 0, and 1, negative 2, in the hope that I will not see, so this is our f of x, in the hope that I will not see something like this, and the quadratic function on top of it. Okay? So that's why I use two different colors. Where red ends, green starts. And the range is determined from the lowest y value till the largest y value. So in this case, the range is negative infinity to infinity. Any questions on the piecewise defined function? Yes.
I don't have a question about the piecewise function.
Yes.
I was curious, if we make the table in our work, if we make a mistake on it, would we lose any points for that? Or
well, I have to look at what type of mistake. So you're talking about the table of ordered pairs?
Yes.
Well, the thing is that if you normally, if you make a mistake here, then it will trigger a mistake here in the graph.
Okay.
So yeah, so I want you to pay attention, be careful.
Okay.
Good question, thank you. Other questions before we move on? Anyone?
Yeah, I have a question.
Yes?
Yeah, so I still want to understand why we used 0 for the second function, given that x is strictly greater than 0.
Correct. If you don't want to use 0, I completely agree with you. Then you will have to start. So if not 0, you must start at 0 point. You see my point?
Yes, I do.
Good. Is it clear now?
It is.
Because if you start at 1, then you lose infinitely many ordered pairs. Infinite. We do not have enough life to go from 0 to 1. There are infinitely many values. So we start at 0, but we leave it as an open point. The point does not exist. The point where the function is defined at 0 is here, not here. But if you start at this point and omit this, because you're starting at 1, then the graph is incorrect, because you are missing the graph between 0 and 1.
Okay.
Better?
Yeah, that's better.
Excellent. Very good question. Anything else? Okay, so please practice. I have tons of other examples in the previous semesters. This creates some sort of issue with some students, and I hope that that's not the case moving forward. So this was the first topic I wanted to talk about. The second topic, before we even start 2.1, the second topic is the difference quotient. What it is and why do we use it and what's the whole thing with it, because the entire calculus is based on the difference quotient. Okay, so let's take a look. Here is a function. Here is point P. Here's point Q. And they have, of course, x coordinates. And I'm going to say this x coordinate is x. And Q is very close to P. So assume that, please, that I zoomed in. Because if I have point P here and point Q here, I can't explain anything. No one will understand what I'm trying to say or do. So assume that I zoomed in. And these 2 points are close to each other. So how close? This distance is very tiny. We're going to call it little h, lowercase h. So then obviously this is x plus that little thing. So can anyone give us the y coordinate of P and the y coordinate of Q? Oh, I'm sorry. Can anyone tell us this, the y coordinate of P and Q, please?
Would that be where the difference quotient comes in, the formula?
Oh, we haven't talked about it yet.
Q is f of x plus h.
Thank you very much. Brilliant. Thank you. And the y coordinate of P?
Just f of x.
Thank you very much. Excellent. Good. Does everyone understand that? This is crucial. Does everyone understand that? So if this is 5, this will be f of 5. If this is 10, this will be f of 10. If this is 11, this will be f of 11. Everyone okay with that? Agreed? Okay, I'm assuming you said yes. Okay, so let's suppose we want to find the average rate of change of f of x between P and Q. Well, anyone remembers the formula for the average rate of change for a function between 2 points? It's okay if you say no, and I'll put it in. I'm just pushing my device further. So the formula is f of x2 minus f of x1 divided by x2 minus x1, which is nothing else but the slope of this line. So this line is a secant line. It has nothing to do with trig. It only says that it crosses the graph of the function in more than 1 point, 2 or more. It's a secant line. So as you see, the average rate of change of this function between P and Q is the same with this formula, which is the same with the slope of this line. Would you agree? So I'm going to write equals and write the slope of PQ. Would you agree? Yes?
Yes.
Good. So now let's use, this is the general formula. Now let's use what we have in our graph. Can anyone dictate?
So would you have f of x plus h minus f of x?
Excellent. Over x plus h minus x. Brilliant. Thank you very much. You notice that I can simplify these two, positive and negative. So then the slope of PQ, which is the average rate of change between these 2 points for the function, of course, f of x, is nothing else but f of x plus h minus f of x divided by h. This is the difference quotient. So it's the rate of change